Hey everyone, welcome back to the lab. In this video, we're going to be talking about how to get started with F# using Entity Framework as your ORM, which is your object relational mapper, which allows you to access your database without writing whatever kind of query language it is that you usually need to. All right, so Entity Framework is the most popular ORM in the .NET community. It's been optimized and battle-hardened through years of enterprise use and thousands of development hours, or actually years. However, this popularity is mostly concentrated in the C# community. The F# community typically shies away from it as it's seen as a bit too abstracted from the underlying database technologies, usually SQL, though sometimes a different query language. And this is common in a lot of, F# is one of these, but also a lot of functional communities. They try to stay away from like these technologies that are a little bit more object oriented. So a lot of the libraries and like C#, Java, etc. have like a long history of object orientation. So they have these really cool, good libraries, but you kind of have to build it in this opinionated way that they want you to do it in. And that often breaks a lot of the constraints around, or at least a lot of the design decisions that a lot of these functional programs kind of go towards, which is trying to make things really simple, straightforward, easy to read, no magic, no random side effects everywhere. And so that's the main reason that F# community and a lot of these others kind of shy away from these things, even though they're really good libraries. So for a time I was in this boat, utilizing raw Dapper for handling my SQL queries and all my projects built with Cloud Seed. Dapper F# is also popular, but I like to minimize my use of niche DSLs as much as possible. So raw Dapper, if you haven't used it, it's basically like an in-between. You still are writing raw SQL, but you don't have to like parse the returned like raw data objects into your like C# object. It's going to do that mapping for you, but you're still doing raw SQL. So a lot of people like this because they can write really performant SQL. There's like not much translation layer. If you're good at SQL, you like this, there's no magic. And then Dapper.F# is a common one for people who are like having this problem like me, which I'll talk about in a second. But it basically adds an extra layer of like utility functions so that you can kind of write these SQL queries without writing any SQL. So it's closer to what Entity Framework does, but like not all the way. But the reason I don't like this is because it's another like domain specific language to learn. And I think like for me, I want to minimize the amount of DSLs I'm using because each of them have so much like random niche edge cases and I don't want to have to like keep up with all of them. So I try to minimize it to only mainstream DSLs that are popular, battle hardened, that are actually useful, and try to keep everything away that I don't need. So over time, I found this approach of using, raw Dapper to be very tedious and risky, requiring lots of manual repo boilerplate and non-type safe raw string querying. So even when you have these helpers and stuff, there's still just a lot of extra stuff you have to do. And I kind of found it taking way too much time and mental overhead for like just like changing how I'm querying something, which I really didn't like. A lot of people will fight me and say that like it's not risky to do SQL if you just know SQL, but like I kind of am like the reason we have types, the reason I like types is because it gives you guardrails to stop doing dumb bad things. And so this like way of querying without any types at all is like the opposite of that almost. It's like basically as far dynamic as you can go. Like it's worse than a dynamic language because at least it can have like linters and help you and stuff. But this one, it's like you really can't find it till runtime and only on runtime when you access this one part of the data model, which just doesn't seem as good to me anymore. I'll probably have a whole post on why I'm kind of falling out of favor of Dapper, but that's outside the scope of this post. Okay, so in this post, what are we going to do? We're going to be exploring Entity Framework as an alternative ORM for F#. And the main question I'm trying to answer here is how can we use Entity Framework for simple CRUD operations in F#? Okay, so in this post, we're going to explore an example project that I built using Entity Framework as its ORM. This is kind of it from a high level. So the app layer is just F# with the Giraffe Web API. This just allows us to simply hit it, make sure it's working, see that it's like returning stuff. The data layer here, I'm using DBUp for data migrations, just so I don't have to like manually run the SQL every time. Entity Framework for the ORM, because that's what we're actually showing the example for. The database I'm using is Postgres. Love Postgres. My go-to, other databases are good, but Postgres is like, the Simple Scalable System, really good at most things. And then for hosting it, I've containerized this this with Docker and Docker Compose just to make like killing and restarting super easy, and hopefully anyone can do this if you have Docker installed. And if you've been following along, you'll notice that this is very similar to Cloud Seed, and basically I use all of my projects start as Cloud Seed, and then I just remove some parts that I don't need because most of my projects need similar things. This is my F# project boilerplate, which includes a web API, data integration, and containerization out of the box. So if you haven't seen this, it basically looks like this, but it makes building examples like this little web API super fast, and that's why I always start with it. Okay, so a lot of the components of this app are unnecessary for this tutorial, so we're not going to go into them in great detail. However, I believe it is important to build tracer bullet examples that approximate real-world use cases to prove that it's not so contrived as to not be useful. So here we are. Yeah, I think a lot of examples, they're like so contrived that they're not even useful for people after the example. So hopefully by like making an example app out of this, you can at least see how it like fits together. And hopefully that means it's more actually useful to you after this. I don't know. Let me know if that makes sense or doesn't resonate. Okay, so in the rest of this post, we're just going to be zooming in on the app domain and how we configure and use EF for our CRUD data operations. So we got our app, which is going to have our models and commands or queries. I like to separate all of my kind of IO things like this. And then for the data layer, this is where we're actually going to be using Entity Framework and how we crucially set that up in an app environment. All the project source code is going to be available. So in this post, we're going to be going over the Entity Framework and F# code, and that'll be in this kind of like copied and pasted in this post, and we'll talk about it. And then also the full project source code, which I'm demoing from, that's available to Minions members, and you can find it on GitHub once you join. And this has just got, this full project that you can run here, and then it's got like a bunch of other example projects I've built over the years. Okay, now before I go into the actual post and how to do this stuff, I do want to show you the example project, how it runs, so you can kind of see like what are we making here. And so here I've got that project pulled up. You can see that it's the same as the GitHub, or just inside this F# Entity Framework example. And then I'm going to run this, which is basically just destroying any of the containers that might have existed, rebuilding them so you know that this is like building from source, and then actually spinning it up. So let me make this bigger. Okay, and it just said that it ran DB up here and that now it's listening. So let's come back over here. This will be on localhost 5001. This is a previous version. Let me reload the page and you'll see what happens. And basically what it's doing is on every reload, it's going to send a create command to go create a new, what I'm calling a sentinel. It's just like a little data object. And then it's going to return all the sentinels that it has. So you can see that every time I'm reloading, it's creating new ones. And each of these is just an object that has an ID field, which is a GUID. And then it's got a data field, which is going to be JSON that also just holds a GUID. But the idea is that I can show you how you can expand this to use both like top level SQL fields, but also how you can like encode full objects as JSON. So if you're more like the NoSQL approach or hybrid approach like that, you can do that with this approach as well. All right, so that's what this post is building. If you get the full project code, you can again see it here for Minions members. But now let's dive into just the kind of like specific F# Entity Framework code. All right, so Entity Framework is a full service ORM officially supported by Microsoft. It allows you to define your models and configure how they map to the underlying data store in code, which we'll show you. And the cool thing is that this allows you to do all your data accesses with your standard list operations, like link, without needing to write any SQL or query syntax. And this is how we're able to get that like type safety, the ergonomics of like not rewriting all these like non-type safe raw SQL or query strings, whatever, query works with your data store. And side note, link is actually what got me into like functional programming and C#. When I was writing C#, I was annoyed at like all the boilerplate, but I was also annoyed like I couldn't write everything in link, and I felt like link was what I wanted to write everything in. And by looking around, I started to notice that like a lot of these functional languages basically all interact over lists very well. And then you start to realize that like, oh, you can code in basically link code. And that's what got me into that. Little aside. If you're not from, like if you are a .NET person, you probably know what Entity Framework is. If you're not and you're coming from JavaScript land, I think it's most similar to Prisma. I'd say Prisma is, I think, one of the most popular, one of the most liked ORMs in JavaScript land. And this is basically, I'm not going to say it's a copy of Entity Framework, but like they're very similar. So if you like Prisma, you'll probably like Entity Framework as well. Okay, so the first thing we got to do is we got to install the Entity Framework data provider. So we actually need to install Entity Framework. EF is a translation layer which allows us to model our data in code and translate it into the data store paradigm of our choosing. This means you need to find and install the appropriate provider for your data store of choice so that it knows how to do that translation. So here's the list of Entity Framework data providers. You can find the one that's matching what you're building. And remember that like it is this translation layer, so it actually supports quite a lot of things. So you got SQL Server, SQLite, you can do an in-memory database, you can do Cosmos DB, Postgres, MySQL, Oracle, it looks like. So a lot of different things, and it theoretically should be able to be extended over to even non-relational things, I would imagine, though I don't see them here, like Mongo. Oh, here's Mongo, stuff like that. So in my case, I'm building with Postgres, and the listed data provider for that is NPG SQL, Entity Framework Core Postgres. So we can just install that from NuGet, which is, the package manager for .NET. We also probably want to install the data store package. So this is optional, but usually a good idea. The Entity Framework data provider we installed above allows Entity Framework to integrate with our data store. But often we'll want to do a few other things with our store, like building a type-safe, properly formatted connection string. This is mostly what I use it for. Most reasonably popular data stores have a package like this, so I'd recommend installing it as well, even if you don't use it yet. It's usually a direct dependency of your EF data provider as well. Typo. For Postgres, this is the NPG SQL package, so we might also want to add that one as well. Okay, modeling the domain. With our dependencies installed, we can start modeling the domain. Personally, I like my domain to be data store agnostic. This means it shouldn't know where it's being stored, which in my experience allows me to model the domain more authentically without unnecessary complexity from implementation details. And in my experience, this is the core of what makes software good, is how close can you model the actual problem without needing to do crazy stuff just to support your implementation. I think the closer you get to the problem, the simpler it is, the more it scales, the more systemic it is, as in the more reliable, less dumb problems you run into. So I like to do this. This also fits into like your onion architecture and stuff, where you're trying to make your core domain kind of like its own ecosystem, it's its own model, and then you just allow the outer layers that are going to hook into external things like your data store, stuff like that, to deal with the implementation details. So to this end, we're going to be modeling a very simple type that just holds some strings. Note that I am letting the data store leak a little here, as I want to show how we can utilize Postgres's JSONB columns. So I'm kind of like breaking what I just said here, but I do think in a lot of domains, you might want to let it leak a little bit, because sometimes that's actually simpler overall. And so here for this example, I think it is, and this is actually how I usually model my data as well, realizing that there's probably going to be some top level things that I want to have very structured, queryable, important things that are basically keys at the top level, and then things that are a little bit more weak, or that I think might change a lot, kind of inside of a easier to manipulate object. So here we have Sentinel, which is our outer type here, and then I have Sentinel data, which is the inner type that's going to map to our JSONB column, which is how you can store raw JSON and query it very effectively inside Postgres. A lot of databases have something like this, but I think Postgres is the only one with JSONB itself, so you might need to do some changes depending on what your provider is. And so this is what it looks like. Just got a simple module here. We just got our Sentinel data, which just has a name on it, and then we've got our Sentinel here, which is the full object using our data. This is again going to be the JSON object, and then just has ID on it. We do have to use CLI mutable here, and so this is, I think, where a lot of people in the F# land, they see this and they're like, object-oriented, side effects, get out of here. But as we'll see, this is like basically the only thing that like infiltrates our domain for the most part. So I think it's okay. And what this is basically doing is saying like, hey, we still can't mutate these things. Remember, all types in F# are immutable by default. So this still allows us in our code to not mutate it, but it's saying, hey, some like underpinning things that like say they'll like declare themselves as unsafe, they need to be able to access this stuff. So that's why we need this here. Okay, so now that we have this simple domain model, next we'll create the SQL table that will hold this data. So my project uses DBUp to handle data migrations, but you could run this manually as well. And all we're doing is just creating a simple Sentinels table. It's got an ID field. This is going to be the primary key. And then we just got a data here, which is a JSONB column. And this is where our blob of JSON will be. Okay, now that we have both the domain and the SQL table defined, we can configure Entity Framework to map the two. We do this by creating a data context. EF calls this a DB context, which we then configure to tell it what all the data is and how it maps to the underlying data store. Examples of this are like how to connect the actual data store, the types that we want it to use for whatever it's doing, like its columns, for example, the names of things, stuff like that. So here in the Sentinel data context, creating like a persistence layer, we're just opening our entity framework core here. We're opening the domain that we created above, and we're just creating a type. And so this is a little bit classy, which again, a lot of people in F# try to avoid, but classes, if they're holding data, I think is a great way to hold data together. And we do need to do this for entity framework because it again is kind of like this object-oriented thing. So we can't go pure functional here, but once you have this like set up, it's actually quite easy to use, as we'll see later. So anyway, we're creating this type, and we're just going to allow us to pass in connection string, and this is going to allow us to build this thing a little bit more functionally as needed, which will play nicer with our F# later on. Then we got to inherit DB context because this is just how an entity framework works, and then we're going to create a private field, which is going to be a DB set of Sentinel, and you'll have one of these for every table. So if I have Sentinels here, this would be here. If I had blog posts, I'd have one for that. If I had users, I'd have one for that. And we're not setting a default value here, which again, F# doesn't like, though this is very common in object-oriented programming where you create these things and they're just like nullable, but then somehow in the grand scheme of things, it like gets filled in. So we do have to provide a decorator to say like, this is unsafe, let it do that weird unsafe stuff. And then we're going to make this public member. And this is what's going to allow us to access this internal DB set. And so we got to give it a get. So in C#, this is like the my property get set. This is what we're doing. So for get, we're saying you can access our private member. And then for set, you're going to give us an S, and we're just going to set the Sentinels to that. Now we got to override this thing on configuring, which is going to tell the DB context how to build itself basically with options. And the main thing we're doing here is just passing in that connection string we had. I'm using Postgres with the NPG SQL package, so that's why I'm using it here, but your data store might have a different one. So if you're using something else, just check that. The next thing we got to do is override the on model creating. And so this is how we're actually going to, like on configuring is how we configured our ORM to connect to the data store. But on model creating, what we're doing is we got to configure the ORM to understand how does our domain models map to the actual data store. And now this is going to be very verbose and it doesn't feel great. But one thing I like about this approach as opposed to the raw manual repo approach is we do this once in one place and then we can use it everywhere else without that leaking. Whereas if you're going like the Dapper raw SQL approach, this kind of leaks into all your repos and often actually leaks outside of your repos, which I think is just worse. So here I'm just saying, hey, this is the Sentinel section, and basically for everything on Sentinel, we're going to map it. There's another way to do this also, which is a property-based, I think, approach, or it's got decorators. I don't like it because that would infiltrate the domain, so this is why I'm doing it here, but just know that's an option. So the first thing we're saying is like, hey, this Sentinel entity, this actually maps to our Sentinels table as we created in that SQL script I showed you earlier. Next I'm going to say is like, hey, it has a key, and that key is the ID property. And now I got to say, hey, the way that this maps is our Sentinel ID field has the column name ID, and that's how we're showing that it has that. And then we got to do the same thing for data, but we also want to say that it has a column type of JSONB so that we can basically tell NPG SQL it knows that it needs to be doing that JSON serialization on both ways, and that's how we get that functionality. So it is a bit of code, but once you kind of like start using this, it's pretty straightforward. It is verbose, but you kind of need it to be verbose to do this translation for you. So it's a trade-off, but I think it's a pretty good one. Okay, now onto the CRUD operations with F# and Entity Framework. So now that we've got our ORM configured, let's go over how to actually perform these CRUD operations from our F# app. Now, if you're new to F#, this code may look weird. Get more familiar with formatting F# functions the right way. It's a post I wrote a few weeks ago, and I was actually formatting F# functions the wrong way for a few years, so don't do what I did and hopefully read this. So the first thing we've got to do is actually set up our data context for use by the rest of our app. I usually like to do this at the composition root, and for a web API, this is typically where I am building our dependencies and mapping routes to handlers. So if you're coming from C# land, you're often using like autofac or I don't know, that configure services thing, which I think is fine. And a lot of people in F# use that as well, but personally, I think it's still a little too magical and I don't like it. And what I like to do is basically build up my dependencies manually. And I found that this works pretty well for the kinds of simpler apps that I'm building. But yeah, you might have a different experience. So anyway, with the basic manual dependency injection approach, we can simply create our connection string, configure how to create the data context with it, and pass it down to any services that may want it. And so what I call these things is a service tree, and every domain I give it a service tree, and it's basically saying these are the things I need to operate. And when I find that I need a new dependency, I basically just update this type. type, and then at the composition root, like where I'm setting up the routes and stuff, I will construct it something like this. So we know we need a DB context. So I'm going to give it a function that it can call, and it's going to then configure this thing. And so this is great because I can put whatever I want in here at the composition root, and the, inner domain doesn't know how to create it. It just knows if I call this, I get this thing. And so it's very simple because we, again, are able to pass in the connection string. We can create this pretty functionally, even though it's like this more object-oriented thing on the inside. So yeah, in the above code, I'm creating what I call a service tree, which is essentially a type-safe register of any IO or dependencies a domain needs. Here we give it a function it can call to create the configured data context. Okay, so let's start with C, the create of CRUD. So to create a Sentinel, we can simply create our Sentinel object, add it to the data context, and save the changes. And so this would be in my commands file. And so we have a create Sentinel command async. We're giving it that service tree, which I showed you earlier, which just has a DB context available on it. And then it's going to return an async result of either Sentinel or one of these errors. So we're basically just opening up an async block. We're going to say use DB. This is like using in C#. Basically, we can grab this thing, and then as soon as this goes out of scope, it'll be disposed of, which you always want to do with expensive resources. And good idea to do that. The next thing we're going to do is we're just going to create a Sentinel. And so we can see again that we're creating this all in our domain land. We're not talking about data land or persistence land. It's all just domain. So we just create the Sentinel. I'm just setting it to a bunch of GUIDs. And then this is where we actually access our persistence. So we're saying db.sentinels. This is that DB set we had earlier. We want to add this new Sentinel to it. And then we got to ignore this. Now this is a little non-functional because we are relying on some side effects here, but I think for the ergonomics, it's definitely worth it. And then the next thing we have to do is this is just staged. We haven't actually done anything. And to actually make this persist to our data store, we have to call save changes async. Should always use async if you can. And then what we got to do is we got to wait task because this is again a C# library. It's going to be using task. So we just have to convert it over to F#'s version of async. And then what we're doing here is getting lines changed. And the reason is because this is our best way of knowing whether this worked or not. And so basically this is how we're creating our result later. So we're matching lines changed with if it equals to 1, we're going to say it's been okay. And we're going to pass back the Sentinel we just created. Otherwise, we're going to say, hey, we get an error. We weren't able to create this for some reason. And that's create. Pretty simple. Just kind of like use the dbset.add and then save changes, and that's EF for you. Okay, read. So the next thing we'll do is we'll move on to how to read from our data. This one has a bit more conversion from C# task and link to F# async, but for all the conversions, it's actually still quite readable. Here we take an event with an ID attribute and we try to find it. If we find it, we return the result.OK Sentinel. Otherwise, we return result.error. And so I didn't show you event, but you could imagine it's just like an empty object that just has an ID that you might be looking for. And this is kind of similar to how you'd pass things from like your web API layer down to your actual domain. And so again, it's going to have the service tree, all the dependencies it needs. It's going to take the event that it's looking for. It's going to return this async Sentinel or error, and we're going to use DB. And then here we got a little bit of link, and it's a little weird, but this is basically like you're writing your SQL type in a type safe manner. So in my opinion, it's like better than SQL in basically every way. So we're going to access the DB context we have here. We're going to say what DB set we want to act on. We're going to filter this DB set, and I added this in here. You don't actually need to do this, but for me, this wasn't coming out as an option like I wanted it to. So I did this, and basically we're filtering down to only things that match. And so if anything matches, I'm saying this is an option. Okay. This is some things here, and that makes it an option. And then I'm saying if there's nothing there, then I want you to say it's an option.none. And then I'm going to call singular default async. So this is either going to give me the sum s that I had, or it's going to give me the none because nothing's there. And then we just got to translate it from a task to async again. And then based on that, we can say, hey, if we actually found the Sentinel, we're going to do okay. And if we didn't, then we're going to send back an error. Yep, and that's read. Now I didn't fill out update and delete, but we can talk through them. But I think it's pretty easy to figure out from those two examples. Basically, it's the same, right? So update, you just get the desired one you'd want out of your DB. Then you just update its values in memory. And then you can go and save your DB context back. And then for delete, it's the same, but instead of using add like we used here, you just do remove. And so if that thing was tracked, if the key, I think it uses key to figure out which one to remove, then it will just remove it from your data. All right. So personally, I found EF with F# to be much more ergonomic than Dapper. There are a few bits of ceremony required for the C# F# translation, but ultimately they're small and not too bad. And I think the big wins for me are like it's type safe and it's very flexible. So like that configuration I did at the beginning means that I can leave all of that stuff inside of the DB context and I don't have to worry about it leaking to the rest of my domain. Whereas with Dapper, you kind of had to rewrite SQL for every new version of like a select statement you'd want, which just like isn't very flexible. And like, yeah, you can get ultimate performance out of it, but like, does that matter? And in most cases, no. What really matters is your DevX. So I think this is a trade-off, but it's been a good trade-off for me. So the full project source code is here on that GitHub repo, and it's available to Minion subscribers. So check that out if you want to get a hold of it. If you like this post, you might also like some of these. So if you want to build a simple F# web API with Giraffe, check this one out. If you're interested in all the libraries and why I picked them, you can look at building a full stack web app with SvelteKit and F#. And then if you're interested in CloudSeed, which is the project boilerplate that I use to start all my projects, you can check out Up and Running with CloudSeed for a full tutorial on using that. That's it for this video. Thanks for watching, and I'll see you in the next one.